100 years ago, the National Advisory Committee for Aeronautics, known as NACA, established the first civilian aeronautics laboratory, what is now NASA's Langley Research Center in Hampton, Virginia. From the beginning, Langley engineers pioneered technologies that help all of us travel safer, farther, and faster. Langley's early years focused on solving the fundamental challenges of flight. During World War II, our engineers tested planes like the P-51 Mustang in the nation's first wind tunnel built for full-size aircraft. Changes they made to these aircraft to gain speed and use less fuel helped win the war. As Langley engineers pushed the aeronautics envelope, they partnered with the military on an experimental aircraft that could fly faster than the speed of sound. And in the Bell X-1, Air Force pilot Chuck Yeager flew into history, becoming the first person to break the sound barrier. But that wasn't fast enough. So researchers at Langley went back to the wind tunnels, and by 1959, the X-15 climbed to hypersonic speeds, traveling 5 times faster than the speed of sound, paving the way for spaceflight. As the space race transformed NACA into the National Aeronautics and Space Administration, America's human spaceflight program began at NASA Langley with Project Mercury. Langley tackled the challenges of spaceflight, trained astronauts, and successfully managed Mercury, going on to play major roles in Gemini and Apollo. The Moon became the next goal for America. Langley led the Lunar Orbiter program, which not only mapped the Moon, but chose where man would leave those first footprints on its surface. And the 12 Apollo astronauts who made those footprints came to NASA Langley to train. Langley engineers also developed the Lunar Orbit Rendezvous concept, an idea that allowed those astronauts to fly to the Moon and return safely to Earth. Atmospheric science work began at NASA Langley in the early 1970s. As researchers learned more about the air around us, they improved measurements of Earth's atmosphere, detected dangerous pollutants, and forever changed our understanding of the air we breathe. But planes that flew higher and faster raised concerns about environmental impact, so NASA's science went airborne. By taking instruments to the sky, Langley had a new perspective on our atmosphere. Using what we learned about traveling through Earth's atmosphere, researchers began to figure out how we could land on other planets. NASA Langley led the first successful U.S. mission to the surface of the Red Planet, with the Viking 1 landing in 1976, setting the stage for our journey to Mars. NASA's space shuttle was an essential step on that journey. Langley evaluated shuttle designs, improved materials, and tested landing systems crucial to all 135 shuttle missions. Easier access to space meant more satellites that could be used to observe Earth's atmosphere from above. Learning more about our atmosphere helped us understand the thinning of the ozone layers and its long-term effects. For decades, Langley's instruments and spacecraft have studied air quality, pollution, climate, and the energy from the sun, helping us protect our planet today and in the future. With an eye toward energy conservation, Langley Aeronautics engineers developed winglets, saving billions of dollars in fuel and reducing pollution. In the search for even greener, quieter aircraft, researchers returned to Langley wind tunnels and computer labs to design new planes like those with blended wing bodies. NASA Langley Research Center continues to create firsts in aeronautics, science, and exploration, inspiring future generations to make the next giant leap for humankind.